Lesson 1. Topic 2, Lesson 1, we're talking about compound probability. We're going to look at probability displays. We're going to talk about frequency tables. In fact, our list of key terms for the next slog of lessons is supporting the idea of representing a scenario with multiple events or situations, and then being able to calculate the probability of how likely something happened given those two events interacting. Definitely highlight the vocabulary words: two-way table, frequency table, categorical data, qualitative data, two-way frequency table, contingency table, relative frequency, and two-way relative frequency table. By the way, data. Data is the better way to say this. This is data. Data is that character on Star Trek. Learning goal. Go back. Go ask your parents about that one. Your grandparents even. Like, did they watch Star Trek? Do they know that data? Anyway, moving on, LeBron. Nerd stuff. Compound probability for data. Compound probability for data displayed in two-way tables. Determine the probabilities of compound events for data displayed in two-way tables. Determine relative frequency of events. Those two high-level sentences will become more clear as we go through this lesson. What is a compound event? What are we doing when we display data? What are two-way tables? What are relative frequency tables? If those are things you're like, you're saying words right now, maybe write them down and plan on becoming aware of what they're talking about as we go through the next lessons. That's good notes, good note taking. You can do this. Okay, let's spiral review. And I also want to acknowledge this is spiral review for some of you, but maybe not for all of you. So I'll take a little bit of time to outline it, explain it out. A quiz in a magazine contains 5 true-false questions. The questions are written in a language you do not recognize. So you don't know how to answer them, right? What is the probability of guessing the correct answers to all 5 questions? This notation here, P for probability, T for guessing correct, true. Because there is independence where guessing correctly on the first question doesn't mean you're going to know how to answer the second question and answer it correctly, all the way up to the all 5 questions. T, I guess, is the wrong one. They're not all true. It's all correct. I need to use that language instead of the other one. The probability of guessing correctly, because you could get true or you could get false depending on which way the question is worded, what the knowledge about that question is. Correctness could be a true statement, could be a false statement, but did you get it right? The probability of getting a correct answer is 1 out of 2. And it does not influence the next question and your probability of getting the next question right. Correct. 1 out of 2. In fact, all 5 questions, just by guessing, have a 1 out of 2 chance of being guessed correctly. Sometimes when we give you a true-false test question, in math or in history and science and other places, we give you a lot of true-false questions because the more true-false questions you have, the less likely it is that you're just a good guesser. And if you guess like to the value of an A, my gosh, take some money with you, go make some gambling because you apparently have some luck that you could, cash out on. Not going to happen. You're guessing, just purely guessing, just 5 questions is going to give you a 1 out of 32 chance of getting it right. Now, there is some playing the odds. What are you willing to accept as okay? Hey, I'm good if I get 3 of them right. All right, we can do the probability of getting that right. It relies on combinations. It relies on looking at the relative frequency table, something like that. Some data display to calculate, all right, how many of these can be acceptable correct answers? Let's go to question 2. What is the probability of guessing only one question correctly? Well, that means the probability of only one of the 5 are correct. It'd be the probability that the first is correct, or the second is correct, or the third is correct, or the fourth is correct, or the 5th is correct. So out of all of those displays, this would be the sample space of getting the first one right, but none of the rest right. Or getting the second one correct, but nothing else right. So each of these have a 1 out of 32 chance, 1 out of 32, just because that's what probability is. It doesn't care about rightness, wrongness, or a pattern. It just says 1/2 times a half times a half times a half times a half, 1 out of 32. Or 1/2 times a half times a half times a half times a half. 1 out of 32. So all of these have a 1 out of 32 chance of happening. And I hope you can see it in the video. It goes from not correct, not correct, correct, not correct, not correct. The location, which question is the not correct question, is the correct question out of the not correct, is moving from first position to fifth position. So all in all, you're adding up those 5 fractions. 1 plus 1 plus 1 plus 1 plus 1, 5 out of 32. The probability of guessing only one question correctly is 5 out of 32. So even then, you stand a very low chance of doing well, like at all. Maybe you can guess like 2. Maybe you can guess 3. If you're like good with guessing 3 out of 5 questions correctly and getting a barely passing grade or pretty much a failing grade, that's on you. We're going to talk about compound probability. We're going to talk about data displays. There's some good stuff happening here. Stick around. Pretty knowledgeable, pretty intelligent conversation. I hope you learned something. Like, comment, and subscribe. See you in the next episode.